Hello children, the continuation of electricity, that factors on which the resistance of a conductor depends. See, the resistance of a conductor depends upon its length, area of cross section, material of the conductor. The resistance is directly proportional to the length of the conductor and inversely proportional to the area of cross section of the conductor. So R is directly proportional to L, R is inversely proportional to A. Or we can write R, which is equal to rho L by A. Rho is the proportionality constant called resistivity of the material of the conductor. The SI unit of resistivity is ohm meter. Conductors like metals and alloys have low resistivity, 10 power minus 8 ohm meter to 10 power minus 6 ohm meter. Insulators like rubber, glass, that and all have high resistivity, 10 power 12 ohm meter to 10 power 17 ohm meter. Now, resistors in series. See, when two or more resistors are connected end to end, that is, the second end of the first resistance is connected to the first end of the second resistance. Like that it is connected, the positive and the negative terminal, like in cells. The same way in the resistance series, which means it is connected like this. The resistance are said to be connected in series, which you are seeing on the diagram. It is between the points A and B. The three resistors were connected. That is R1, R2, R3. So that the same current flows through each resistor. That is, there is only one path for the current to flow between 2 points when same potential is applied across the combinations. Right. So, the current in all the resistors is same. The total voltage, that is potential difference across the resistors, is equal to the sum of the voltage across each resistor. That is V, which is equal to V1 plus V2 plus V3. So, the equivalent resistance is the sum of the resistances of each resistor, Rs, which is equal to R1 plus R2 plus R3. We'll see resistors in parallel. See, in the same way, the resistor is connected, but here the resistor in such way, the first end of all the resistance are connected to the first common point, and the second end is connected to the second common point, so that the same potential difference is applied across each of them. They are said to be connected in parallel. The current enters the first end and leaves at the second end. But in parallel arrangements, there is more than one path for the current to flow between the points A and B. The current takes the three possible paths, say like I1, I2, I3 across R1, R2, R3 respectively. Right. So, when three resistors R1, R2, R3 are connected in parallel across AB, what we said, the potential difference, the voltage in all the three resistors is same. So, the total current, the sum of the current, what we said, the possible way, I, which is equal to I1 plus I2 plus I3. So, the reciprocal of the equivalent resistance is the sum of the reciprocals of each resistance. So, 1 by Rp, which is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now, see the diagrammatical representation. See the first diagram, the symbol R1, R2, R3 given, and see the diagram. In series combination, the same current will pass through each resistance, we said. So, if V1, V2, V3 are the values of potential difference across R1, R2, R3. So according to Ohm's law, what it will come? V1 which is equal to IR1, V2 which is equal to IR2, V3 which is equal to IR3. Then by combining all these three, V which is equal to I into R1 plus R2 plus R3. So that in series, R which is equal to R1 plus R2 plus R3 we have given there. The second diagram, if you look at there, in this parallel correction, the connections, 3 resistors R1, R2, R3 and a battery V, that is V volt, is connected across them. Such a potential difference across each resistor is V volts, which is equal to the potential of the battery. So if I1, I2, I3 are the values of the current through each resistance R1, R2, R3 of the parallel combinations. So the current in the main circuit, we can say I which is equal to I1 plus I2 plus I3. The potential difference across each resistor is V, which is common. Here also when we are applying Ohm's law, we will get V which is equal to I1 R1, I2 R2 and I3 R3. Then only we said we got 1 by Rp which is equal to 1 by R1 plus 1 by R2 plus 1 by R3. We can use this for our numerical purpose. Thank you, students.